Josh, you sound like you're kind of picking it up, so I'm going to have you explain it. Juan, you're going to be asking questions. So I got your attention here. So the idea being that I am right now saying that if I am given anything that looks like x squared plus x's plus numbers, we've already seen that we can organize this like this. No matter how many x squares you give me, I'm going to put them up here. No matter how many constants or just regular numbers you give me that are at the end of all that, I can put them down here. And no matter how many x's I have in the middle, I can split that up somehow and put some up here and some down here. Is that fair, Josh?
Yeah.
Dwan, is that fair?
You said again, like every time I'm looking at it, by just like.
That's cool. So I'm saying we're starting with this. I'm giving you some amount of x squares, some squares. I'm giving you some rectangles, like B rectangles. And then I'm giving you some number of random like unit things called C. I got C of those. You good with that?
Yeah. So the BX is both of them?
Exactly. I'm going to split this up. So I'm going to say I got AX squared, and I can always split this up into two numbers. I'll split this up into one group of X's and another group of X's. So I got to be careful when I do that, but I can absolutely do that. And then I've got C down there. And if I can do this in a good way, I should be able to organize it all in a rectangle. We agree?
Yeah.
All right. And then we also said that I could look at this as one way of thinking about it. But Josh, you were talking about how you were curious what happens on the tops and the bottoms to make that happen, right?
Yeah.
So here's what I'm going to do. I'm going to draw that in a separate picture. We'll keep our brains straight on that one. So the idea being that you said, I wonder how I would make that happen. That's a great math question. And we talked through it and we said, well, it's going to happen if I have some number. I need a new number. I'll use D. I have some amount of x's up here and some amount of x's down here. I'll use different letters because they could be different. But then that's going to get you some number D times some number E of x squares. Is that true?
Yeah.
Dwan, you feeling it?
Yeah.
All right. And then over here, we said that this is a place where I would always want to put some number. Maybe I'll call that F. And I could put some number down here called G. And if I do F times G, that just gets me a number in the bottom right corner that happens from F times G, right?
Yeah.
Mm-hmm.
Okay, good. And then up here, what would this one be?
E is gonna be F E X.
There you go. Or can I write it like this? I'll keep it alphabetical just because my brain wants it that way.
Yeah.
Okay, so E times F times X is a way of thinking about how you would get that answer. What about this bottom one down here?
Wait, I got a question.
Sure.
So E go first before the F?
It doesn't matter. If I say 2 times 3 or 3 times 2, if there's just numbers, it doesn't matter.
All right. It's gonna be D G X.
Where'd you get the E from?
Oh, I'm gonna say D G or G D.
Very nice. All right, Josh, you feeling this?
Yeah.
Okay. So here's what I'm looking at. Imagine that I'm just like playing around. Y'all got to stop thinking about it like we're looking at math to get right answers. This right here is just two ways of looking at the same thing through a different perspective. I've got one that says I start with stuff. I got another one that says I create stuff, right?
Yeah.
So here's my question. Aren't they the same thing?
Yeah.
Yeah.
Josh?
Yeah.
So here's my question. If I went back over here to my symbols, couldn't I write this as D times E times X squared? And I could write this one as E times F times X, and this one as D times G times X, and this one as F times G?
Yep.
Yeah.
All right. Why would I do that? I don't know yet. I'm just playing. Let's think. Oh. Well, normally I want to take things like this and I want to write them in multiplication. Oh, that's crazy. Hey, take a look at this. Haven't we seen this before? Where I kind of group this stuff?
Oh. Yeah, I seen that before.
Yeah.
What do we do? What can I factor out?
I said X
An X? Anything else?
and E.
And an E. Very nice. That would leave us with a D and an X, and then an F, and that'd be it, right?
Yeah, just F.
All right, Dwan, you're going to do this one. What about this next parentheses? What can I factor out?
I say DX or
Well, take a look. You're looking for things that are common between here and here.
a common between there and there. F.
You see an F in both those?
Yeah, I did F in both of them.
Where are you seeing F over here?
So I'm gonna go down what, in DG?
Yeah, I'm looking. What's common between DGX and FG?
Oh, none. Oh, G. So
G, there you go.
It's gonna be G parentheses DX plus F.
DX plus F, very nice. Take a moment and pause. Let's go back to our picture. Where do we see all this? What you all just did, well, here's what I did. I found that I wanted a group, and I wanted you to just pay attention to two of these at once, right?
Yeah.
Watch how I would show you that in the picture. I want you to pay attention to just these two. You see how they're the same two that are in my parentheses up there?
Yeah.
And then I said, what's common between them? And what'd you say, Josh?
EX.
Do you see how that's the shared thing between them?
Oh, yeah.
You say that again? Hold on. Explain it again.
So I was saying, look at this first set of parentheses, and I said, let me show you where that's in the picture, and that's right here, right?
Yeah.
What did we say was common? What's the common factor?
Can you
When I was in fifth grade, there was a kid named Ali in my class.
X?
That was my
EX?
parent.
EX. And look at what's the only thing shared between both of those.
X?
So every other week,
Look right here.
interpreter
EX?
came to teach the class
EX.
American Sign Language.
So that's what it means, is if I have EX groups of all this stuff, you can think of them as what I get when I do that, or where I started from. We're talking about the same thing all the way through. We're just changing our perspectives.
Once he became comfortable, he was less
Right.
shy and more interactive. He used sign language to ask our teacher questions and
Right,
answer.
okay.
Feeling that one, Juan, or is that feeling like it's kind of taking a sec?
This kid kind of iffy.
I did not know what sign language
It's getting kind of iffy?
Yeah.
And when I
All right. Here's a way to think about it. Multiplication just means groups of groups of groups, right? Like 5 times 4 means 5 groups of 4, right?
Yeah.
Well, that's what I asked you way back when we were making this picture. I said, what is E times X times all of this stuff? And you said, no problem. You started grabbing things and multiplying them together. All I'm doing is the same thing in reverse. If I have all this stuff, where'd it come from? And you said it came from EX. And I say, yeah, no kidding. That's what we did over here.
understand
So if it feels weird like this, think about it backwards. If I take E times X and I multiplied it back in, that's how I would get everything up here, right? And isn't that exactly what happened to get me everything right here, is that I just multiplied it in?
Yeah.
So that's all that we're talking about here, is we're just talking about it being the same thing in the picture as what we're doing in the symbols.
Right.
Okay? Good.
Yeah.
Now, here's my next question for you. I'm going to throw this one to Josh. Josh, what do you see that's common between the first parenthesis and the second parenthesis thing?
Where?
Over here. This stuff right here. All this and all this.
What do F?
Think bigger. Look at right here. Isn't all this stuff the same as all this stuff?
Oh, yeah. Yeah.
So take a look at what we can write. Is it okay for me to say I have EX and G groups of all this?
Yes.
Yeah.
And take a look. That's exactly what we started in our picture. Look, I've connected them. If I have DX plus F groups of all this, then I get everything in the middle. And everything in the middle is the same thing as the top. And there you have it. This connected to this one.
Hold on.
All right. I'm gonna take this thing.
Where you get EX per G from?
Josh, do you see it?
Yeah. You from outside the parentheses.
So how many DX plus Fs do you have right here, Dwan?
Wait, like where?
Watch right here. I'm going to draw the arrow again. Right here.
Can you see it?
Here, look at the pointer.
You have any EX we got?
You have EX of them, don't you?
Yeah.
And then over here you have g of them, right?
Yeah.
So look, you have ex and g dx plus f's. Groups of groups, multiplication.
Oh. Yeah, I see. Yeah, I see.
That's weird, right?
Yeah.
All right, so this is the power of just changing the perspective and keeping the meaning, is you all get to play. Now, here's the part that takes a true mathematician. This one's a hard one to see. This one's really, really hard to see. First, let's talk about what happened in the story. If we wanted to do this, because this is what we're about to do in all the problems you're talking about, Duan, we're going to start with what we're given. The very first step is that we're going to have to break the middle into a very particular way. We haven't talked about how to do that yet. We just said that if we could, all else is gravy, right?
Right.
And then everything down from here was just what we have titled factor by grouping. It's group, factor, group, right? Or group, factor, factor. So now here's the only thing that we're missing is we don't yet know how to do this step. We know it can be done, but we don't know how to do it. Like if I gave you numbers, you wouldn't know exactly how to split them. Like if I gave you 5, you're going to split that into 1 and 4, 3 and 2, 0 and 5. What are you doing? That's not quite clear yet. True?
True.
Josh?
True.
All right, here's the part that's absolutely bonkers wild. A mathematician, after looking at this and looking at this and looking at this, has said that, you know what? There's a pretty simple way to look at this. All you need to do is split up. And this is wild. I got to find a way to kind of draw all this. All you got to do is split this up in such a way that the two numbers you have here multiply to the two numbers that you have right here. And I'll show you why that is. This is just A. This is just C. A times C got you D, E, F, and G. And look here. D, E, F, and G.
Wait.
So really, this whole thing here equals EF times DG, which is B1 and B2. And that's the missing link. That's wild.
Yeah, it is wild because you lost them.
There's a lot going on here. Pretty much, we're gonna need to kind of take a look at a picture here. But do you see? First of all, do you trust me that A times C, which is just this part here and this part here, give me this part here and this part here?
Yeah.
Or I shouldn't say do you trust me, but do you see where that comes from?
Yeah.
Do you see how those letters, D, E, F, and G, are the same letters that appear in a different order in B1 and B2?
Right.
All right, so here's the way we can think about doing this one. I'm going to give you an example, and this will kind of be the end one for today. So imagine I was giving you something like, oh, let's do 3x squared plus, let's do 6x plus 3. I think that works. Let me check in my head. Okay, I think that one works. So we have all this. We're about to try to run it through this process. Are we all on board?
Yeah.
All right. First thing I need to do is I need to split this up into such a way that I get the same thing here and here multiplied everything that I get on the outside. In other words, I need to take my A term, which is here, and my C term, which is here, and I say that A times C gets me 9. Do we agree?
Yeah.
Wait, I got lost.
That's okay. Take a look here. So I've given you a problem. I've got 3x squared plus 6x plus 3, and I said take A and C, which you said is the first number and the last number, right?
Yeah.
Multiply them together, and that gets me 9, right?
You get 9 squared to the second.
Hold on. I'm looking at A times C.
Oh.
So A is a number, C is a number. I multiply number times number. I get 9.
All right.
Let me know if you see all that.
That's it.
Yeah.
Okay, good. Now, here's this is the part that we would not have understood if we hadn't seen it before, if we hadn't broken it down exactly like we all played with. Hidden in this 9 are all the components here and here. They're disorganized and mismantled, but this times this got me everything that's circled on the inside. Like all the components hidden in this 9 are 2 numbers. True?
Yeah.
And they're going to add back up to B, aren't they?
You said to B, right?
Josh, you seeing that? How they kind of ripple back up this chain and they add to B?
Yeah.
So that's the trick. Here's what we're going to do. To capitalize on all this, we're going to organize it in a grid. I'm going to say A times C is 9. In other words, hidden in my 9 is everything that I need to eventually add to 6. Fair?
Mm-hmm.
Dwan?
I got lost.
All right. 6 is the number they add together.
Yeah.
And 9 is the number that has all the components. We agree?
Yeah.
All right, so I need something that multiplies to 9. In other words, I need to account for all my components, and it needs to add to 6, because that's what I eventually need to break apart. So somebody give me a number that adds to 6 and multiplies to 9.
Multiply 9.
3 and 3.
You agree, Dwan?
Yep.
All right, so here you go. This is a 3, and this is a 3. So that's the missing piece. So now that we've found that missing detail, and we did it because we understood what's happening way, way, way behind the scenes, let's start to use it. And we're going to see that it actually goes really, really quick. So it's like we did all of this time and effort building a machine and building our understanding that now we can just make these problems go fast. So here's how we can do it. Take your original problem and break it up using that first step we were talking about. Break up that middle part into the 2 pieces that you said have everything that multiplies to the A and the C together. In other words, we've kind of got that missing link. Then from here, look back over here at our problem. We've split it up. Now I'm about to do some factoring, and eventually I will be done. So let's do it. Factoring out from here, I'd factor out a 3x that's common in both this and this. That'd give me x plus 1. Over here, I could pull out a 3. That would give me x plus 1. And then together, I think we have 3x plus 3 and x plus 1.
So anytime, like when it's square and you break it down and put the 3x somewhere, so it's gonna be like get shorter.
Yeah, so the idea being that this is what real mathematics is about. Real mathematics is playing over here until we find something interesting, so that when we come back to numbers, I can do it in about 4 lines of work, right? Take something I've never seen before. I didn't even have to include all this stuff up here. I could get rid of all this scratch work and show you what the minimum amount of stuff that we really had to communicate was. I had to get rid of this and 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 this. And we said, if you want to factor, in other words, if you want to try to organize all of this stuff, any problem, into multiplication, you want to organize it into groups and groups, then no problem. I'm going to separate the middle in such a way that it multiplies to A times C, and so that I get everything I need to add to B. And then I'm just going to do my factor by grouping after that. 2 steps, or 2 ideas. Split,
Okay.
factor by grouping. But it's kind of cool, like you all seen that all we did here was by playing around and really playing, like nothing more than playing. There's that one little insight where we say, look, there's a link between the things that are in A and C together and the things that are in B together. And we say, well, that's kind of cool, because if I can find a number that satisfies everything I need in A and C, and it satisfies everything I need in B, then I've got every tool I would ever need to be able to group this out the way that we've been practicing.
Right.
Does that feel better, Josh?
Yeah.
It's kind of cool that all comes just from playing, right?
Mm-hmm.
Like there's not a procedure there. There's not a textbook telling me what to do. That's from playing. And the cool thing is now you can factor any problem really, really quickly. This is called the AC method. You just draw a little cross over here to organize your thoughts. You say, what are things that multiply to A times C and add to B? And then after that, you just run it. Okay, so on the test, this is the part that I need you all to be able to do on the test. But if I ask you why, you're going to say, well, I split it up in such a way that I was able to build my rectangle by finding common factors, or in other words, finding common sides of this thing. That's the logic I really want you all to take away from this, is that there's a specific way that if you can split things up, then you can organize all of this as if it was a multiplication problem. In other words, you can organize all of this as if it was the dimensions of a rectangle.
Okay.
If you've got that part down and you understand why we're doing it, then memorizing all this crazy over here, this is the stuff I walk you through in lecture. You don't have to reproduce this. You just have to know where it generally came from, and that it came from looking at a rectangle by either how it's built or what I have in it. How you doing, Josh?
I'm good.
Did you like this, or does this just feel annoying? What do you think? I thought if you had a couple of mind-blowing moments.
Yeah, it kind of like it surprised me.
It's fun when that does that. This is why I love math. This is why I teach it and why I study it, because those moments, those are like a drug. Those are fun. All right.